If X is a random variable to represent the weights of deer in a national park, it says the distribution is approximately normal, which is a good key that we can use a normal distribution to answer the question or find the probability. Mean is 70 kilograms and a standard deviation of 8.9. The probability that a single doe is undernourished or less than 61 kilograms is the probability that X is less than 61 kilograms. We talked about two ways to do this in class. First, you could convert it to a Z value. So if X is 61, that Z would be 61 minus the mean of 70 divided by the standard deviation of 8.9. And then second, we could find the probability from the curve. What's the probability that Z is less than this Z-score, where the table can give us the area to the left. And that's strictly just look up in the table the Z value that we got from this calculation. That will strictly tell us the area to the left, and since it's a left-tailed question or a probability of less than, that's a pretty direct answer. To do these in the calculator, use the normal distribution. Second, variables key opens the distribution menu. We want the normal CDF. The lower value, the place where we start caring about this probability, would be at some lower limit. For this weights of deer, 0 is a perfectly acceptable lower limit. We want to find the probability or the area up to and including the 61 kilograms. The mean is 70, and the standard deviation for deer were 8.9. So this probability is 0.15559. But if we look next door to the 9, that would make the 9 round up, so the probability is 0.1560. If the park has 2,700 does, what number do we expect to be undernourished? Well, we just found that 15.6% are undernourished, or that's the probability of them being undernourished, so we want 0.156 times 2,700 does to tell us the number that are this 15% or 15.6% of 2,700. To estimate the health of the population, park rangers use the average weight of 50 does, and they think that that should be more than 67 kilograms. If it's less, then we think maybe the population is undernourished. So the question is, what's the probability that the average weight, that's important, is less than 67? So it's no longer the probability of X, but the probability of X bar is less than 67. Again, we can convert it to a Z-score by hand method. Z is the average value, 67, minus the mean, 70, divided by, and in this case, because it's an average that we're talking about, the standard deviation of the average is the standard deviation of the population divided by the square root of the sample size. So here we'll use 8.9, but then divided by the square root of 50, because it's a sample mean. In the calculator, you'll need to make sure that you use parentheses correctly. So parentheses 67 minus 70 divided by 8.9 divided by the square root of 50. I don't want that square root, but I need to cover the downstairs in parentheses. So in the calculator we put parentheses here. That gave us a Z value of negative 2.38. Because it's still a left-tailed probability, we're interested too in the probability that Z is less than negative 2.38. Make the curve, read the value directly from the table for the left tail. Again. Or in the calculator, we can put all of this again using the normal distribution. Normal CDF, minimum still 0, upper now 67, mean still 70, but the standard deviation is divided by the square root of the sample size because we're doing this to a mean. We get a probability of 0.0857, which would make the 5 round up to a 6. If you want to compute this probability that x bar is less than 71.3, we do the same thing, still 50 doughs. So now we make the same assumption before, but now the probability that x bar is less than 71.3. Z would be 71.3 minus the mean of 70 divided by 8.9 divided by the square root of 50, or we can do it again in the calculator. If you have more questions, just let me know.